Hello, everybody. My name is Alan Friedman, and for those of you who don't know me yet, I've been in the vibration analysis field for 33 years, and currently teach vibration analysis classes with certification, and I travel all over the place, and I meet a lot of people, and I think this is a very timely topic. So in the last, let's say, 5 years, I think there's been more than 100 new companies with wireless sensors coming on the market. And it's the biggest change we've had in the vibration world in quite a while. And it's going to be interesting to see how it plays out. So, a lot of them maybe don't know that much about vibration. They just kind of know about sensors, or they know how to move data around, or they know how to make apps and dashboards. So I'd say the quality varies quite a bit. At the same time, there's a lot of benefits to having eyes on the machines, every hour, every 15 minutes, instead of once every 2 or 3 months. And so there's a big question about, when do you make the decision, all right, we're just going to put sensors on everything and get rid of the guy walking around? And so that's sort of the question I hope to answer. So as the Vibe Tech does battle with the wireless sensors. So these are just some examples of some of the new systems on the market. And when I'm talking about wireless sensors here, I'm referring to ones where they sit on the machine permanently. They wake up maybe every 15 minutes or every hour. They take a reading. They send that reading out. So there's other wireless sensors that are Bluetooth that you sort of walk around and you just stick it on the machine and press the button and take a reading. You put it in another machine, push the button, take a reading. So I'm not talking about those. I'm talking about permanently installed ones. Now, a little bit of history. One of the issues with online monitoring in general is the cost of actually installing the cables is usually way more than the cost of all the sensors and the software. And so that's been sort of a big problem in the past, and the reason why a lot of people didn't go online. And so the idea of having wireless sensors where you literally just stick it on the machine, you set up a gateway or something, which you might be able to just plug into a normal outlet that's already there, and you're up and running. So that's pretty attractive to a lot of people. So some of these systems are remote services also. So the wireless company will take care of all the infrastructure, so you don't have to worry about getting your IT department involved. This is also a big change. So in the past, anything you want to do remotely, if it went through IT was also often a big barrier to that. So the idea that you can put these sensors on, they have their own network, maybe their own cell network or their own Wi-Fi. Somebody else from outside the plant's taking care of all that. That solves a lot of problems. Some of these are standalone. Some of them are subscription-based. Some of them, the companies provide remote analysis services. So basically, they put the sensors on your machines, all the data goes to them, and you interact with the system, usually just through a website browser, and they do all the reporting and all that stuff. Okay, now because there's so many companies that are new, time will tell how many are still around in 5 years. There's a lot of marketing, versus reality. So we'll have to sort through some of that. Also, in general, there's lots of different applications for vibration monitoring. So I actually gave a presentation this morning where the first third of it was all about what are your goals? Why are you monitoring this equipment? What do you hope to achieve? What's the money aspect of all of this? How does it help you in planning? How does it help you with production? How does it help you with safety and avoiding catastrophic failure? So I would say before buying any product, you should be really clear about what you want to use it for. Oftentimes, we look for the shiny product, and we think, oh, that's going to solve all of our problems, and we just get whatever new thing is on offer without ever really being clear about what we're going to use it for and how it's really going to solve our problems. So I think before you even delve into this world, be really clear about the problem you're hoping to solve, and also the type of equipment you're monitoring. That's also kind of a big deal with this. Okay, so this is a pretty short presentation, and I'm obviously not going to cover all of it. Okay, other things you might see, like tomorrow when the showroom opens up and you get to see all the vendors and products and things, you'll hear a lot of marketing buzz. So most of these new companies have AI in their name or machine learning in their name. And a lot of the marketing is everything is automatic. You just put the sensors on and walk away, and it automatically does everything like magic and solves all of your problems. So just take some of that with a grain of salt, or at least do your own diligence, do your own research. See what makes sense, what does not. Okay, so now the battle begins. Who will win, the Vibe Tech or the wireless sensors? Okay, so let's start with costs, the money aspect. So I think probably, at least in my mind, there's some number where if the sensors cost under this number, then yes, we're going to get them. Even if we also had somebody walking around taking readings, in my mind, there is some number where it just makes sense. But that being said, we'll kind of go through it. Right now, we have labor rates. So you have to pay somebody to walk around, take these readings, and they have to be trained and all of that. It takes a certain amount of time, so that's a certain amount of money. On the sensor side, you have the cost of the sensors, cost of installation, and you might think that once you install it, you're done, but these guys have batteries. They require maintenance. People overhaul machines. They walk up to the machine with a hammer and they whack that thing off of it, the sensor, because they don't know what it is. And then they repair the machine, and now you have to get another sensor. Or when the machine is overhauled or a sensor falls off, it has to be put back in the same place. It has to be put back in the same orientation. So the sensors actually require some management. So not only do you have to maintain them, but you have to have somebody on site that knows how to maintain them and that understands what the issues are. That it makes a difference if you take it off of this machine and you stick it on another machine and you don't tell the people who are providing remote services that you put it on a different machine. Like, you would think that's obvious, but this is where a lot of these programs fail. So you're still going to need someone on site that knows something about this system. Additionally, in terms of people, you're going to need somebody on site that knows how to interpret the report, right? So you might have somebody doing this analysis for you. Maybe they give you a report. Maybe they give you a bunch of graphs. Do you know how to interpret that? Do you know how to check if they're right or not? Do you have enough knowledge to, figure out where to go from there? So I think you still need somebody on site with some training. Okay, another thing with the wireless sensors in terms of cost is many of the systems are subscription-based. And so it's not like you pay a one-time fee to install all these sensors and then you're done, but rather you're paying a yearly fee for all this infrastructure, all the IT stuff, and data storage, and of course, as a separate thing, if the remote people are doing analysis for you, there's of course a fee for that. Okay, so that's ongoing. All right, so that's making our Vibe Tech happy as these costs sort of build up on this end. Maybe he won't lose his job so quickly. So the people on site that do have to have some awareness of this, they also require training. So there's going to be some investment in making sure people on the site maybe are Cat 1 certified or Cat 2 certified in vibration, and at least know how to interpret the reports and have a realistic grasp of what these systems can and cannot do. So somebody, again, on site has to have that knowledge. Okay, on the other hand, that balances out with your Vibe Tech. So if you're going to have somebody walking around take the readings, they also have to be educated, certified. And whoever's doing the analysis on your end, if you're doing a walk-around program, obviously they have to be trained. And as people come and go, they will require additional training. Okay, so on this side, we have the remote analysis services. That's another cost, of course. And on this side, we have the time to go out and take the data. All right, building up. On this end, program management. So that's leaning towards more costs on the wireless sensor end. But what happens when you train your employees and they get really good at their jobs? Sometimes they go find other jobs. And so employee retention is an issue here. If you're going to have all the expertise on site, then you have to maintain that. You have to worry about people coming and going. A way to solve that problem is to make sure your program is a set of processes and procedures. So that's actually something I talked about in my presentation this morning, how you shouldn't be totally dependent on one person. How your system is set up and how it's managed should eventually be person independent, and somebody coming in who has a minimum amount of training should be able to pick up from where the last person left off. All right, now let's just say all costs are equal. So let's say that same amount of money, and now we're going to talk about what are the other pros and cons of each approach. Let's start with the quality of the sensors. So a lot of the new wireless sensors are based on something called a MEMS sensor. And a MEMS sensor is on a circuit board, and they're small, they use very little energy. You probably have one on your phone. Actually, I forgot I could show this again. So this is a little meter just looking at the sensor on my phone. You see the green line. And if I rotate my phone this way, you see the red line. Anybody have an idea of what that's measuring in this direction, those sensors? Gravity. Yes, so this is an accelerometer. It measures acceleration. We're all experiencing 1 g of acceleration right now, which is why we're not floating off into space. So because our cell phones have these little MEMS sensors in them, and there's a billion cell phones, they're cheap, easy to make, and pretty much, small, don't use a lot of battery power. So this is what a lot of these new systems are using. Our walk-around systems, we use something called a piezoelectric accelerometer. So it's a different design. These sensors have a little crystal inside them. When you put a force on that crystal, it puts out a voltage. The more force you put in it, the more voltage. And the quality of the data between these two can vary quite a bit. So this is also where it comes back to what are your goals and what are you measuring? Is the quality adequate or not adequate? So a part of this I'd have to give a longer discussion about really what these measure and do not measure accurately and what's needed. And again, it will depend on what you're using it for. But generally speaking, as just a general statement, the MEMS sensors are not the same quality today, especially as you go to the lower ends. Now, just a little bit more detail in case people are interested. These MEMS sensors just come on a little circuit board. And a lot of the companies are buying that circuit board from the same vendor. And that vendor has tested that sensor, and they say that sensor on the circuit board can measure very well out to this frequency or something. And a lot of these companies are using that as their spec. This is what our sensor does. The unfortunate part is when you take that circuit board and you actually install it in the physical sensor you're going to buy with all the other circuitry and the battery and all that stuff, it does not measure the same thing. And there's a lot that goes into sensor design that I'd say a lot of these new companies probably don't know very much about. And so just sort of dropping this little circuit board into something, putting a battery on it, and saying, here you go, here's the spec, it's probably not meeting that spec. When you buy a piezoelectric accelerometer, it usually comes with a calibration curve. That sensor was tested. Your particular one that you bought, that curve comes with it. You might find that some of these new companies do not provide that with their sensors. And we'll just leave that there. Maybe there's a reason for that. Okay, so data quality, I'd say, it varies. But again, it depends on what you're trying to measure. The wireless sensors operate on batteries, so one of the big issues is battery life. Now the question is, what are you trying to measure? So when it comes to vibration, there's different measurements we can take. The most basic one is called an RMS overall reading. And this is one number, which is like how loud is it or how much is it vibrating. And the idea is we can trend this over time, and we can say if it goes up, oh, it's vibrating more, there must be a problem. And that does not take a lot of battery power to collect. It doesn't take a lot of battery power to send out. But it doesn't tell you what problem you have. It just tells you it's vibrating more. So again, it comes back to goals. If all you want to know is it vibrating more, that's good enough. Without going into detail, I don't know if people have vibration background or not, but there's another simple reading, which would be an acceleration peak-to-peak reading, which is one number. And it tells you if you have high-frequency pinging, like ping, 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 ping. And that's something that happens when a rolling element bearing begins to fail at a very early stage. So that is something that you could measure. You can send that other value out. It's also very easy, doesn't use a lot of battery. Okay, on the other hand, if you want to know what fault you have to send out more complex data. It takes more time to take that reading, uses more battery. It's also more data to send out. And often for some of these sensors, the actual transmission of the data is what kills the batteries. So there's a balance. What are we measuring? What do we need to measure? What's our application? Okay, now on the other hand, let's stick to the wireless sensors. Most of the new wireless sensors companies have one sensor. And if that sensor doesn't work for your particular application, then you're kind of stuck. So they're not plug and play. I can't just buy brand X wireless sensor and use it with brand Y software, or at least most of them are not plug and play. Which means once I kind of lock into one provider, then I'm just stuck with the one sensor they have. And if that doesn't suit all of my needs, I'm stuck, or I have to get another system, and now I have two different systems I have to maintain. When it comes to a walk-around program, you can plug any sensor you want in your data collector. And so then you're using the best sensor for the job. So not only in general is the quality better, but you're also getting the right sensor for this particular application. And just to give you an idea, if you have something like a screw compressor, they put out a lot of vibration, and you would need a less sensitive sensor. Whereas if you had something like a machine tool or a CNC machine, they hardly vibrate, and so you'd have a much more sensitive sensor that can pick up these lower values. And again, the wireless sensor, there's just one. That's the one you bought. There we go, stuck with one sensor type. Okay, if you were to pay more, you can get equal quality. At least let's just assume that would be possible. If we spend more money on the wireless sensor, we can actually get a piezoelectric wireless sensor or a better designed MEMS sensor, and we could potentially get similar or equal quality. Okay, so now we'll sort of make those equal. Okay, a lot of the wireless sensors just wake up on a schedule, like once an hour, or once every 2 hours, or once every 15 minutes, and they take a reading, they send it out, and they go back to sleep. So a quick question, if you test a machine that's variable speed, one day at like 1,500 RPM, and the next time you test it, it's at 1,700 RPM, do you think it will vibrate differently? Does that mean there's something wrong with it? No. So how do you set alarms on that? If the sensor's dumb, it just wakes up, takes a reading, goes back to sleep, wakes up, takes a reading, goes back to sleep, and you don't know anything about the speed because it's not measuring that, then your data is just like, so how do you set alarms on that? How do you make sense of it? Another question, let's say you have a pump and one day it's at 40 PSI and the next day it's at 60 psi. Is it going to vibrate differently? Yes, it is. So again, how's that system going to deal with it? Now, it depends, again, on the type of machines you're monitoring, which system you go with. It is possible with some of them that you could set up something like a tachometer, and you can timestamp that data with your wireless sensor, and it can just check, was I in the right condition or not? So you can basically sort it on the back end. Okay, we'll come back to that in a minute. If you're doing the walk-around system, this guy can check test conditions. So he walks up to the machine, he looks at a speed gauge, or he looks at a pressure gauge or something, and goes, oh, not in the right condition. Either I call an operator and I ask them to put it in the right condition so I can take my reading, or we just come back later and test it tomorrow, or something like that. So that's a benefit. He can deal with changing test conditions. Or he can call an operator and control the test. So can you please run this pump at 60 psi, at 1800 RPM for 5 minutes so I can take my reading? So we can set up a test, and that's not something we can do the other way. Okay, that said, what if the machine is really variable, like an overhead crane or a shovel or something, and it's changing all the time? Or you're in a company like a pharmaceutical plant where you make a batch of drugs and it takes 24 hours to make that batch of drugs, and during that 24 hours, everything is completely automated and everything's changing speed and turning on and shutting off, and you cannot touch it. Unless the guy can find a part of that where it is repeatable, like maybe he shows up at hour 23 and he can take his test. If he can't come up with something like that, even the manual guy is going to have a hard time figuring out a solution to how to get a repeatable reading. Okay, which brings us back to this side. If instead of having a dumb sensor that just wakes up every hour and sends data out, what if the sensor is smarter and it can take a speed reading or a load reading? Or a lot of us already have other sensors on the machines. We have pressures, we have motor current, we have temperatures. Maybe these are all going into a SCADA system or a Pi database. These are all time-stamped. So if you have a smart system, it could look at all the timestamps and it could say, okay, during that test, this was in this operating state and it goes in the apple basket. And then 3 hours later, it goes, oh, now it's in this other state and it goes in the orange basket. So a smart system could potentially, even if it wakes up every hour, regardless of condition, it could potentially sort the data on the back end and get repeatable readings. That said, you'd have to do due diligence and see which systems support that and which don't. And my guess is most of them don't. Not only do they not, but you would have to have access then to that database. So if you have an outside company who's managing this and they're doing the analysis for you, they might not have access to your Pi database. And then if you're going to give them that access, now you have all the IT involvement and security and all that stuff. So although technically it can be done, there's obstacles to doing it, and I'm not sure how many people actually are doing that. All right. Now, there are a couple that I heard of recently that are smart on the front end, where at the very least it can tell that the machine is running. So maybe not that smart, but it's better than a lot of them just wake up and take a reading and send it out even if the machine is off. So some of them, if there's a certain amount of vibration, at least they know it's running. But I saw one that had a wireless tach, and that can actually communicate to the other sensor and say, I'm at the right speed now, take a reading, and it will trigger it to start the data collection. So if you have something like that in the wireless system, that's a big benefit here. So, ideally, if you can automate only testing when it's in the right conditions, there's a huge benefit to that, if the system can do it. All right, so sorting it in the front end or sorting it in the back end. Okay, but as I said, a lot of systems can't do this, so you have to do your own research. Okay, so clear benefits of wireless systems. And that guy looks pretty sad right about now. So one of the big benefits is, mostly when you do a walk-around system, you only take readings every 30 to 90 days. There's something called the PF interval. PF interval is how long from when you first detect a defect in the machine, that's the P, until you have a failure, that's the F. And the idea is if you have some idea of how quickly the asset fails, that tells you how often or how frequently to take your measurements. So you want to take a number of measurements within the time that you think it's going to fail. Does that make sense? So for most rotating machines, it's been fine to test them every 30 to 90 days. Things like rolling element bearings typically fail very slowly. Unless you have a pump and you suck in a rock or something, obviously that's going to fail quickly. But if we're just talking about wear over time, they generally wear out quite gradually. You can find a defect in a bearing a year before it fails, in a lot of cases, even 2 years before it fails. So testing the machine every 30 to 90 days is often enough. On the other hand, there are benefits to taking the data every 15 minutes. So I have a question. What would be a benefit of taking it frequently that's separate from actually catching a quick failure? So obviously, if something fails quick, you'd have a better chance of catching it. But what's another benefit or possible benefit? Yeah, well, you should have a baseline pretty soon anyway. Anybody else have any ideas? No, yeah, so there's an idea that you're keeping a closer eye on it because it's more critical, yeah. But I'm thinking of something.
Budgeting for replacement?
So this is budgeting for a replacement. The idea of that is that we find it early enough so we have time to plan. So that, yes, we want to do that, yeah.
If it was due to lubrication, you can correct that and mitigate that.
True, yeah. If you found a lubrication issue, then you can mitigate that, yep.
Sometimes you can see how different products in your production process impact the equipment operation.
Bingo, that's what I was looking for. So I could have phrased the question another way. So I started surveying people and asking, what did you learn when you started testing the machines every 15 minutes or every hour that you didn't know when you were testing them every 30 to 90 days? And the answer I always get back is how much the operators are damaging the machines by operating them incorrectly. And so that's like there's a long-standing rivalry between maintenance and operations. Maintenance blames operations for destroying all the machines, and operations blames maintenance for not fixing things well. Well, it turns out they're both right. So maintenance also causes a lot of failures. But in this case, you can see you're operating this pump off the curve. If you keep operating it like this, you're going to damage it. You're operating this other machinery, and during this operation, it is vibrating too much. And in that case, vibration is a root cause of failure. Keep running it like this, keep vibrating it like this, it will cause damage. So normally we think of vibration as an indicator. So I have something like a bearing defect, and the vibration changes. You drive your car to work the same way every day. One day you notice a new sound, you go, oh, there's something wrong with my car. We're not saying the sound is causing damage to your car. We're saying the sound is an indicator that you have a problem. So most of vibration monitoring is of that form. So we're not necessarily looking for huge increases in the amplitudes. We're just looking for changes, and we can say what faults we have. Especially bearings don't necessarily cause a lot more amplitude of vibration. It's more about a change in vibration, a different pattern. But at the same time, if you drive your car on a really bumpy road, you will damage your car. So vibration is also a root cause of failure, and we don't want things vibrating too much. Okay, so that's the benefit, is taking data much more frequently to find process-related problems and operation problems. Now, of course, as we said, some things do fail rapidly for one reason or another, and so also by having it on there, you have a better chance of catching that. Yep, so rapid failures. All right, so now we'll give this poor guy another chance to have his job. So clear benefits of a walk-around system. I think the biggest benefit is that guy is a sensor. And when I audit people's vibration programs, often when they have them outsourced, they have people coming in, running routes, and I'll get hired to look at the reports and just give an opinion of whether I think they're getting good value or not. And oftentimes what I see in the reports are missing guards, leaking pipes, missing bolts, cracks in the foundation, broken isolators, and basically 90% of it is things they saw with their eyes, felt with their fingers, not things they found with vibration. And so I would say, if you're going to go online, you still want to have inspection routes. You want somebody whose job it is to walk around once a month and just look for problems with the machines. But on the other hand, if you're going to pay someone to do that, it's not a big deal for them to put a sensor on the machine and take a vibration reading, right? So balance either way. Okay, so also apart from having eyes to see damage and ears to hear damage, you can hear bearings when they're bad, you can hear clunking sounds, you can hear surging noises. All these are indications of wear or machine problems. You can touch, if you have a isolation mount, the purpose of that is to prevent vibration from the machine going into the floor. So you can very easily take your finger, put it on top of the machine, put it on the floor. You should feel a very big difference. Almost no vibration on the floor, a lot on the base of the machine. And if you don't feel that difference, it means the isolator is broken. So a simple test with your finger, not something trivial to do with a wireless sensor. So your vibration sensor might not pick that up or something like that. You can smell when grease is overheated, so that's another thing. Another thing with someone walking around is if they're kind of chatty, that's helpful, because operators often are in front of the machines all day, and sometimes they just come into work and they just feel like something's wrong. And if the guy happens to come around doing his route and he just talks to them, hey, anything new, any problems, anything I should know about? They often uncover a lot of things that way, just having conversations that you might miss with a sensor. Uh-oh. We've already come to the conclusion. Why not have both? So the benefit of the wireless is the more frequent tests, closer on the machine. I've gotten a lot of feedback that even just having a temperature sensor on there, a lot of the vibration sensors have temperature probes also, that finds a lot of stuff. So it comes back down also to the money again. There probably is some price point where it makes sense to have them, even if you're going to send someone around anyway to take the routes. Just because from a financial point of view, why not? If we can monitor these every 15 minutes, that's good. Critical machines, why not? Again, it comes down to the cost benefit, but if something is really critical, if the consequences of failure are really high, why not keep a closer eye on it? Why not test it every hour, every 15 minutes? Again, there's no reason not to. Difficult to access machines. Maybe you have some machines in your site where it's going to take a vibe guy an hour to drive there and climb up some dangerous thing, to put their sensor there, or like a cooling tower or something that you can't access. Why not start there? Put some wireless sensors in those applications that are hard to access or that are far away. That would be another obvious benefit. Variable speed and load machines, again, there's a benefit if it's a smart system. So if it is smart enough to know what speed or load it's under, or if the speeds or loads are pretty minimal and don't change the vibration as much as a real failure would, or entering a failure mode would. Okay, then, as we said, just because you have sensors on everything, you still need somebody on site that's educated, that knows how to interpret the reports, that understands what the system is for, that will maintain the sensors when they fall off and understand it matters how they're mounted on the machine, it matters how they're oriented. So I think it's always good to have in-house expertise at the same time. Also, you probably care more about your plant than some consultant who's sitting in India in front of their computer doing the analysis for you. So I would like to have other eyes on it on my end that's local. Okay, another thing is, let's say you are using simple alarms or something, and you believe you have a vibration problem. What happens next? Oftentimes, especially if it's a high-value machine, you're not going to just say, all right, let's change it. Maybe you want to take some other tests to confirm it. Maybe it's not a simple problem like a bearing defect. Maybe it's more like a structural issue, and you need somebody to troubleshoot that. So having like a data collector, the technology in-house, having someone that knows how to use it, they can now take the extra step. They can take more data types, more complex data, and really troubleshoot what the problem is. Okay, so that'd be another benefit. This was an informal LinkedIn poll I put up some time ago. What percentage of the rotating machines in your vibration program are currently being monitored using wireless sensors? So, yeah, altogether, 50% of people are using some amount of them. This was actually from last year. I'd say the numbers are probably higher now, that more people have adopted this since last year. So yeah, why not put it on some machines, give it a try, see what you get, expand it as it's useful, and still keep your vibe guy employed. Any questions or comments, or does anyone want to add anything else that I missed in terms of the trade-offs?
We have one question back here.
All right.
Hello.
Hello.
My name is Brian. I'm the founder and CEO of iCare. iCare is probably the biggest predictive maintenance company in the world. We have 100 million USD revenue, 850 engineers who are minimum Cat 2, 500,000 assets under monitoring, and this year we installed 100,000 wireless sensors. So I think that, like you, I know what I'm talking about.
Yeah.
First of all, I would like to thank you and congratulate you for this brilliant presentation. And I should hire you as a sales executive for my company because I think we are really checking all the boxes who you highlighted here. But for me, there is a key differentiator, which is safety. I mean, unfortunately, 4 years ago, one of my engineers died by doing his job. He did a crazy thing. He removed a protection grid on an asset to place a sensor for manual data collection, and he died due to that. And every year, I think people doing manual data collection die or are deeply injured around the world. So I promised to myself that before the day I die, nobody will risk his life, her hand or her arm doing manual data collection for predictive maintenance in this world. Thank you.
What about when they change the batteries?
That's a good question. I mean, for the batteries, can't you just wire it?
Well, the point of wiring it is that costs more money. So that is an option to have wired sensors that are powered. Then don't have battery issues. But the installation cost of that can be really high.
But just wiring the battery, but maybe transmitting the signal still.
Yeah, there are
wirelessly.
systems like that on the market, and there's a lot of benefits for that architecture. And some of the wireless companies have both architectures. So they have the wireless system, a sensor itself with the battery, but then they also have where you can use whatever sensor you want. It goes to like a local box, and then that box is wireless. Yeah.
Other questions?
Yeah, up here. Yeah, go ahead.
Hi, my name is Rejane. I'm CRO for Dynamox in Brazil. We are actually having a booth here, so come over and get to know what we do.
Okay.
We do not use the replacement of the battery. Our sensors, we have a family of sensors, and they are completely sealed because they need to be robust for the industry ambient. I like very much what you presented, and come over and let's have a chat on what we do. We have over 250,000 sensors around over 20 countries, in the US as well, still small. So we have some interesting cases where the technology has proven itself. But we do like the thing that people has to be part of the process. You will not get rid of the route inspection. That's our opinion. And we do not do miracles. Not never. Okay? We have to work together.
Thanks. Yeah.
Hey, Alan, so I appreciated your advice on sticking with route-based vibration data collection. I come from a facility that we have instrumented probably close to 800 assets with remote sensors. Actually, majority of them are wired because of where we're at. And most of them are only outputting overall velocity, which has a lot of limitations that you're aware of. But we have also instrumented some of them with bearing defect sensors, similar to like a peak view for bearing issues and whatnot. But the uppers to be were under the impression that once all this instrumentation was put on, that we just walk away and we don't have to go back to any route-based vibration data collection. And so I've been a big advocate of going back to that, as what you mentioned, that there's nothing like being on the scene and with your eyes and your ears and your fingers and whatever, that you might come across other issues that you're not going to see from a trend or information from a computer without being there. So I'm an analyst, so I don't want to lose my job.
Yeah, another problem with the wireless sensors is sometimes the route guys sort of sabotage the program because they feel threatened and they knock the sensors off or they damage them, or I've just heard that.
Did we have
Through the
another
grapevine.
question back here? I thought I saw some hands up.
Anybody else? All right, well, thanks a lot. Contact information, if you took pictures, please put some up on LinkedIn. I'd appreciate that if you don't mind. And public courses mailing list if you're interested, QR codes. And I have another presentation on Wednesday afternoon at 3:15 on KPIs for condition monitoring, and a book signing on Wednesday morning, and my book is in the bookshop. Thanks.